So this is the tower of anomaly problem. So okay, so that's this but a game. So what you need to do is move this 3D to this side, and what the thing is only you can place uh, sticks in a large on top of a large disk. So that means you move this to here, then you can't move this disk to here, right? And what you can do, you can move like this. So that's the task. Now can move this to here, and another thing you need to do this in minimum moves. So how to actually program this? Anyone had an idea about? Come on, you today's session, as you mentioned, it's a discussion. So to uh, make a discussion, there should be at least two persons who are communicating. Can someone unmute and tell me how to do this problem? ළමයි වලට මම ඇහෙනවා නේද? Hello. Okay. Can you help me on do the discussion? Can anyone? Yeah, Kalhar. Can you tell me how to do this problem? Oh, anyone, please? Yeah, I think I have only one number to complete today's practical session, and after that you can email me and clarify any problems. So I will help you on that. And yeah, we need to utilize today's hours. Uh, so can someone help me to do this problem? Then can explain about how to do the coding and all the things. So as I mentioned, so next week you will have your assignment. So currently I have prepared the assignment as well. So not sure, maybe there will be a problem with the about this at our NOS about the recursions and all. So can anyone help me? Like, just need to explain how to do this problem. You already did that in last uh, lecture, right? No, no, no. It's not gonna be conducted in blended. It will be physical only. Okay, you all aware uh, how to do this problem. Uh, then we can move ahead. Can discuss your predictions and all. It's up to you. So you can hear me clearly, right? Oh, okay. Then please raise your hand if you have any like if you had face a problem in doing a lab sheet. Please raise your hand. Then we can discuss this problem. Or you can put a chat uh, even that, and we can discuss them. some of you have mentioned. So can we explain the E part of the third fiction? You mean about the lab sheet 7? Last lab sheet? Lab sheet 7, we find the element which appears the maximum number of times in the array. So what that means is you need to get a count of each element. So here it's 34.5. So you need to count how many 34.5 are here. So there are two, I guess. And likewise, you need to do for all the things. Then after that, you can display like the maximum number of times what the element is. Uh, this here, I guess 698. There are four. Yeah, there are three, four. So I think this will be the answer. 19.4. So how you can do that? Can anyone explain what the equation? I think some of you have already do this one. So students, in the meantime, please do this question. So I will ask you to show the answer for this one. So it is about recursion. Uh, you need to check uh, these let's say to get some maybe integer or string like this, and you need to check whether they are palindrome or not. So in the meantime, I will explain about description. So I will put this to your chat. So find the elements of the maximum number of times there. So, right. Yeah, I'm going to do this exact problem. So I do for some problem, teacher array, let's take, right. So what you need to do is you need to find the maximum number of times. So what you need to have is you need to have a count variable also to get the count, and some temporary count as well, right? So what I'm going to do is I'm going to count each occurrences, how many occurrences are there. If that occurrence is exceeding the current value of a previous one, then I'm changing that value, right? So we need to follow is right. Let's see. Then oh, so um, I'm going to do is traverse through the occurrences. So let's take the first initial. So uh, will count and let's say the current maximum. So I am assign current maxima to the initialize to the initial value. So that means the first element, the zeroth index element is currently I'm considering as the maximum number of elements, and then I'm going to get a count. That means the current considering value uh, is equal to uh, the traversal elements. Let's say this one, or this one. Then I'm going to implement the count. So after that, so after the first iteration, then I will have uh, what is the number of limit, or what is the count after first iteration. Then, then I need to check for the other elements as well. So I do uh, loops. So what happened here is now I am having two loops. So I am considering only this element in the first loop. Then I am going to traverse the whole element, whole array again. And I am checking this element will be can be found in, from the other. So if that's the case, then I'm going to increase the count. So after that, I'm going to assign that to the one count, or to the initial count. See, which translate, right? And what I'm doing is then okay, them from uh, it's less than that means so our initially temporary count will be 0. Then I'm going to increase the count. So temporary count probably it's definitely going to less than uh, the current count. If the occurrences had more than one, then I'm going to assign the max to the current 5. Uh, right. So max will be the current 5, and then the this is the code. So what is the logic here? So logic is I am going to traverse 2 times. So first time I'm taking the first occurrence, and then I traverse the whole thing again to get the count of the occurrences of that element. So it will be count here. And if that count is greater than the temporary count, it is greater than temporary count, I am assigning that value will be a max value, and temporary count will be that particular count. And after do this for the first uh, iteration, then I'm reassign count to 0. Right. So in the second iteration, what happened? So this will be this I will be 1. So uh, J will start from the beginning again. Uh, from 1. So it will recalculate the whole thing again. So again, if the count is uh, the temporary count is less than the count, then it will assign that particular value to this, and we're going to include. So like if you are maintaining maybe a stack or something, then you can uh, the, reduce the doing the same thing again. So here it will do this one for same thing, and this one for this one also for, will do the same thing. So the code, when you're doing the code optimization, you will need to remove them as so I will probably explain in next few tutorials how to reduce that doing the same thing over and over again. There are some tricks also. For this one, I only do the initial algorithm and or do this. So after finishing all of this, we need to print the maximum value. So sign in, we need to do this. So this is School. Yeah, we got 2 as the answer. In the question number 5, the type sheet 7, right? Program the trees in 10 numbers and display the number of distinct number and numbers. So, how can you do that now? So that means what you need to do is you need to remove the multiples, and only you need to show the distinct numbers. So I think we can edit this code as that means if uh, if this happen, if there are multiple elements, so we can reduce that, right? To so this way. So yeah, in that particular code we can only do by using only one iteration. So however, for easy to understand, I will do it by using 2. So my algorithm is I'm going to traverse uh, yeah, I'm traverse for whole elements, and in the next traversal, that means I'm first I will select one, and then I'm going to traverse the whole thing where I can find the same thing again in the loop. Then I will go to the next one, right? So that means uh, we are doing the same thing again and again likewise. So yeah, for this one, so since if I found the same thing, what I will do is I will continue. So that means I'm not going to do anything, right? And we do to this part. So, yeah, for this one, just the print the number. Let's see, put it here. Again, the same thing. We print it here. Yeah. So the my logic was if this uh, current uh, uh, if we find it in again, so like I'm going to continue, and that means we need to get the count. Uh, we can do it this way. So I'm going to assign the count. So this count will be the maximum number of elements. So how you can actually not, without hard coding, how you can actually find this value. In particular in C, what you can do is you can get the size of this array, and since the it is integer, then you can divide the size. Size of an integer, right? So from that, you can get the actual count. It should be cost integer. You can see actually it's working. Yeah, we put 7, right? And what if this happen, we can reduce the count. Right. So in the next phase, from here, so that means you should avoid that occurrence as well. So how you can do that? how to avoid the, if you have already calculated it, so how you can avoid that. Yeah, you can see a problem, right? So that means in the next iteration, we start from this one, then it will going to start from the beginning. Since we already reduced the number of uh, occurrences for this one, then it should not do this for again, right? So we need to have some kind of mapping to if the occurrence is already found. Student, please give me a minute. Sorry, students, for delay. Can you hear me? Okay. Yeah. So I quickly do this question. So the problem is, if you do this for uh, the next iteration, so we need to find a mechanism to remove them as well. So how anyone can uh, give an idea to how to remove that one? That means if you are doing this for this element, we need to find the way to uh, do not check again for the already checked elements. So anyone can give some idea? No? So what we can do is actually, uh, if you already we check that particular element, we can uh, remove it by using some kind of a tag. So that means here for this particular section, there is no any zeros or no any negative. So what I'm going to do is I'm going to change the already checked elements. So that means it's uh, equal to, let's say, -1. So now what I'm doing, I'm going to replace this element with some kind of a tag. So my tag is -1, and I'm going to remove the count as well. Okay. So what that means, if that particular value is a minus L, uh, no, the particular value is less than 0, that means minus value, we can continue the loop. That means this whole loop will be continued. So here also we can do that. Uh, less than 0. Okay. Okay. What's the problem here? Okay. This 4. Now the whole, so we can safely print count and we need to print the numbers as well. F HD underscore informative. there is a problem. Problem here. Yeah, Sahan put the answer to the palindrome. So that in your chat. Is the Sahan answer? So there is a problem. Can anyone help this? The array is less than 0. That means we are continue, and we are doing this again. Continue the array I is equal assigning retrieve. All right. What is the problem? Since it's checking the same thing, it's will check the first occurrence again in this code. We need to remove that one. So how we do this? Let's start by 1 or I plus 1. Then it will be work. So we have 4 occurrences 1, 2, 3, 4, and number of occurrences 4. So yeah, this is the way. So that means you need to have a clear idea about your algorithm, and you need to check it very carefully but where it's going wrong. So in my code, this was the bug. So even it didn't show any error, but in logically there it's a bug. And in your assignment, so there are some uh, bugs like this. That means there will be no any errors, and it will going to execute clearly. But when it's come to the answer, so answer will not that accurate. So you need to fix that bug and resubmit the correct answer, right? So we come to the today's talks about the palindrome. So here, what it happened is, so let's check the answer of the Sahan. This is the Sahan answer. So first, Sahan said, can you explain what this pal means palindrome, and what is the logic behind your palindrome? So he's passing two integers. So if those that integers are okay, so this is checking the first and this L is the last, right? Okay, he's checking first and last. If those are not equal, then return 0. That means it's not a palindrome. And next else, if is less than greater than or equal to 1, no L cell, then he is going to return 1. So what is that logic? You increment the count and count of the initial letters and increment the count of the last letters. Right? After few runs, if and I by 1 and incremented by 1. So what he is doing is, he'll explain here. Let's say some answer. So first he is checking the last element. If those are correct, we can remove them. Then again, these two will be our last element. Likewise, then after that, what happened is the first index of the first will be going to pass the last. That means we are going to check this one first, and then we're going to check the last index, this one. So if that the case, that means it is going to pass for all the elements. That means so this has 2, 3, 4, 5 letters. So the first one. So this is the R will be 0 index, and the last R will be the fourth. Then we check for that one. Then what we are going to check? 1, 2, and 3. Then 2, 2, and 2 again. That means this D. After that, we are going to check 3, 4, and 1. Since this is higher than this one, then that means we have checked all the string. Since if it is that the case, then it should be definitely a palindrome. So what is the recursion? Recursion is, as I explained, take the whole thing, check the first and last, and we can simply say we are removing. Then we are check the again we are checking the first and the last. Right. So this is the way it's doing the fiction. So it's same. The idea is same for this Tower of Hanoi as well. So what that means is, if the Dix count, yeah, we can only reduce to 3. Let's only consider there is only one Dix. So what that means is we need to only move that Dix to here. Then the problem solved. And if there are n number of Dix, what we need to do? You need to pass the first n minus 1 Dix. That means the not the last Dix, but the first n minus 1 to the auxiliary Dix. Right? Like this. That means we have passed the first n minus 1 Dix to this auxiliary Dix. Then we can pass the last Dix to here. Then after that, we can pass the whole thing again to here. So here, this problem we should able to with only 7 more. So I took 9. So there are ways to reduce the moves count as well. Yeah, I think it will be and for the today's session. I have only 1 hour. So if you have any question, you can email me. So be ready for the next week assignment. So it will not going to cover arrays. It will be only up to recursions. So there are problems, the recursions, the spelling rules, and maybe about the strings. But let's say as mentioned here in the palindrome, you need to have some kind of knowledge about a string. So that will be benefited. And be ready and do all the lab sheets and redo them again, find the spills. Like I took the whole hour to do those 2 tasks. But you will not going to have that much of time. You need to do this quickly. So practice more uh, about say programming. Then you will definitely do the whole number of sections on time. So do you have any problems? You can ask now. Otherwise, we can end the session. You mean the palindrome? Uh, since we are doing it in the recursion, uh, since we are doing recursion, this will be the most efficient way. And basically, the most efficient one will be by using only one loop. So the time complexity of that one will be, will be when it's come to the big go. Yeah, we will probably learn of those in on the data structures when you are learning. So for recursion, it's going to have many time complexity because it's a function. Okay, I will wind up the session then. Thank you, students.